What is up, guys? Welcome back to another video. And so this video is about Euler's identity. And Euler's identity is an extremely special formula that was formulated by Leonhard Euler after, yeah. And Euler's identity says that e to the pi I plus 1 is equal to 0. And we're going to go through how this works. So this is the formula, and Euler's identity is, you could think of it as like an example to string theory, because this is a theory of everything for mathematics. So what we're going to go through is why this works and how it expresses a theory of everything. So e to the I, wait, that is not good. So e to the I theta is equal to cos theta plus I sine. This is very annoying. 1 second. I'll just rub this out and give you guys the whole thing again. So it's e to the pi I plus, not there, plus 1. I keep making mistakes like this. Plus 1 is equal to 0. But that looks more like an L. E to the pi I plus 1 is equal to 0. E to the I theta is equal to cos theta plus I sine theta. And how this works is, 1 second, let me zoom out so that you guys can see this better. Let me click that. Yeah, I should be able to move it. Yep. So how this works is, I'm gonna go down a bit so I can draw something else. Let's say you had a graph. This is called a complex graph. And instead of calling these x and y, I'm going to call this real and imaginary. So 1 here and 1 here. Instead of saying this point is 1, 1, you would say it's 1i, because imaginary. So what does I actually mean? So if you didn't know, I means go down to write this. The square root of -1 is equal to I, because a normal square root must always be positive, because -1 squared is equal to 1. 1 squared is equal to 1. So what happens when you do the square root of -1? So every square root has two answers except the negative square root. So if I were to do the square root of 1, it's equal to plus or minus 1. But usually if we're doing distance, time, that sort of thing, you would always just say it's 1, because negative is not appropriate for that sort of thing. But if you're doing abstract mathematics, then you can say that plus or minus 1 works. So therefore, then it arises a question, what happens when you do the square root of -1? And on most calculators, just going to say undefined, unless you go into complex calculating mode. Otherwise, it's just going to keep saying undefined, non-defined, math error, syntax error. So this is equal to I. So the square root of -4 is equal to 2i, or 2 times the square root of -1 should be, yeah. So because 2 times the square root of 1 is 2. And if we were to do it 3 times, then you get 3i. So that's simple. So it's another way of basically counting. So if I had this imaginary graph, and I'm going to draw this in more detail because this is an extremely important topic. I have this graph with I and R, and I have a triangle here. Here we have the right angle, and here is theta. A, B, C. A is opposite, B is adjacent, C is hypotenuse. So we can formulate a squared plus b squared is equal to c squared. That is the Pythagoras theorem. And sine theta is equal to a over b. Not a over b, a over c. because sine is equal to opposite over hypotenuse, so A over C. So, but since A is an imaginary value because it's on the imaginary scale, it's an imaginary over C. B, on the other hand, is not imaginary, which is why when we have the formula that Euler gave us, the second one, not e to the pi I plus 1 is equal to 0, e to the I theta, cos doesn't have an I, because in the diagram, only sine has an I, because only sine is imaginary. So cos theta plus I sine theta is formulated because it's an imaginary sine theta, because this one is imaginary. Now, but then how does Euler's identity actually work then? So, we get the formula again, e to the I pi plus 1 is equal to 0. That if we replace theta with pi, then we get e to the I pi is equal to cos pi plus, and if we just got here, I sine pi. And in radians, there are a pi number of radians in every 180 degrees. So sine 180 is equal to, well, sine 180 is equal to 0 because, well, if you had a 180 degree angle, there is really no opposite, so it's 0. And if you had a 180 degree angle on a cosine and your adjacent would somehow be -1. So if you were to give this in your calculator, cos 180 plus I sine 180, you wouldn't put the I, you just put cos 180, you'd get the answer as this thing. You would get your answer as -1, and on this side, you would get your answer as 0. So what happens is that you can now formulate that this is e to the I pi is equal to -1. And algebraically, you can switch the 1 to that side, which makes e to the I pi plus 1, not here, not the power, it's below, plus 1 is equal to 0. And that is Euler's identity. So Euler's identity is a theory of everything for all of mathematics because it holds all mathematical constants. So it has E, natural logarithm constant, not all of them, but it has most of them. It has E, or not most of them. Then it has one of the most important ones. E, which is the natural logarithm constant. Pi, which is extremely useful for calculating the area of a circle, for example. I, which satisfies the equation I squared is equal to -1. 1, which is 1, and 1 is the thing that keeps any multiplication or exponential difference the same, and 0, which keeps any additive or subtraction equation the same. So you have all these things, and then you have a trigonometric identity that proves this, right? And therefore you have Euler's identity. So this is Euler's identity, and yeah. The name is Euler's identity. You can check it on Google. It's a famous formula. So anyway, thank you guys so much for watching, and I'll see you guys in the next video. Peace.